All right, good morning, everybody. So the last class, we were looking at string length and how to implement string length. And I showed you 3 different ways to implement it. So the first one uses array indexing to access the element out of the string. It looks at the element, checks if it's the null terminator. If it is, you found the end of the string, so you can return the length of the string. The other 2 versions that I showed you relied on pointer manipulation. And so if this is the first time that you're seeing pointers, these are probably hard to understand, especially the second one. The second one is very, just that one fragment of code is quite cryptic if you're not really confident in your knowledge of exactly what the operators are doing. Right. The third one is less cryptic, probably still unusual for someone who hasn't seen the language, who hasn't used pointers before. So honestly, I would be thrilled if you could write the 4th version here. And the 4th version is just a very slightly modified version of the first one. Right? And so in the first version, we're using array indexing to access an element out of the string. Right? For the purposes of this course, if you remember that you can add a pointer, add an integer value to a string, or adding an integer value to a pointer in an array is equivalent to indexing, then you can write the following. Oh, that's not quite right, sorry. Whoop, I have to dereference that. Star. Like that, right? So if you remember that, that is equivalent to a using an index, right? That gives you, that's basically the equivalent of a pointer to the ith index of the string, right? And you can dereference that pointer to get the value pointed at. I think you're doing great in this course, right? So that's the version of string length that I would like you to be able to write when it comes to the exam, right? If you can write the middle 2, good for you. That's really good. But it is important that if you use a C-like language, well, C and C++ anyway, that you do understand how to work with and manipulate pointers. Right. Okay, so let's look at a different function in the string library. So string copy is the string function that you use to copy strings. So it takes in a pointer to a source string, right? Notice it's const. So it's trying to tell you, hey, I'm not going to change the source string when I copy this string. And then it takes in a pointer to the destination string. Right, so this is a pointer to the character, oh sorry, that's a pointer to the character in the string where you want to start copying from. This is a pointer to the character in the string where you want to start copying into, right? They're not necessarily the start of both strings. String copy returns a pointer, and the pointer that it returns is just equal to dest. Now the reason it does this is it lets you nest function calls. Right, so you can call string copy, and then you can put that inside of a call to another function that needs a string. So that lets the other function work on the copied string. Okay, so here's an example of using string copy. So here's our source string. It's just the 5 digits 0 through 4. I want to copy source. I want to make a copy of source. It's an array, so I can't do array assignment. So I can't copy the array just by using straight assignment, so I need a function. So I make sure, so to copy the string, I make a new string or a new array that's large enough to hold the contents of the string, right? So how big does it have to be? It has to be the length of the string plus 1, because you need to copy in the null terminator as well. Right? So here you could put in 6 and that would be fine, right? There's 5 characters in the string plus 1 for the null terminator. So that's basically 6 in this example, right? Call string copy. The thing you have to remember when using string copy is that it's the source that comes second, and it's the destination that comes first. You don't have to commit this to memory. On the exam, you get a cheat sheet. Well, you get a summary sheet. If you look on OnQ, there is an example of a summary sheet that you get for the exam. Right? So you don't have to memorize how all these functions, what the arguments are for all of the functions. Right? Okay, so after copying the string, we can print them out, and obviously we're going to get 0, 1, 2, 3, 4, and 0, 1, 2, 3, 4. Right? So there's the original string, and there's the copy of the string. They are now independent strings. Okay, we're going to call string copy again. This time I'm not going to store the result anywhere, right? So here, this time I'm not going to, when I print the string, I'm not going to print the name, I'm not going to use the name of the array to print the string. I'm just going to use the returned result from string copy. Right, so here's an example of where you might want to use the fact that string copy returns a pointer to the copied string and to nest or to pass the result of string copy to another function, right? And that works the way you expect it to as well, right? There's destination 2. Destination 3, we're going to copy into an existing string, but I'm not going to start copying at the front. I'm going to copy into the middle. So here's the destination string. It's A, B, C, D, E, and then 5 hyphens. I'm going to copy the 0, 1, 2, 3, 4 on top of the hyphens. So all I do is change my destination pointer, right? My destination pointer is now dest3, right? Plus length. So in this case, plus 5. So that's destination 3 plus 0, plus 1, plus 2, plus 3, plus 4, plus 5. So right there is where we're going to copy the source string into. And when you do that, you get A, B, C, D, 0, 1, 2, 3, 4. Right? What else is there? Copy the end of a string into a destination array. Copy the end of a string. Oh yeah, so this is an example showing where we don't have to copy the source string. We don't have to start copying from the front of the source string. We can copy from anywhere in the source string. So here, I'm going to start copying from s plus 4, so the 5th character of s. 0, 1, 2, 3, 4, 5. So starting from the 2, the first 2. We're going to start copying from there. I'm going to copy them into dest4, right? So dest4 becomes 220. Right? So string copy, it's the function you want to use to copy one string to another string. Right? Now, string copy doesn't do any error checking for you. Right? And so most of the standard library does not do any error checking for you. And so there's a couple of issues here. Issue number 1 is you're copying a string into another string. You're basically copying characters from one array into another array. If the destination array is not large enough, well, you've got a problem. Right? String copy is just going to look at the characters in the source string until it finds the null terminator. Right? It's just going to copy characters into the destination array. It's not going to check if the destination array is large enough, because it can't anyway, right? Remember, C arrays, they don't know how big they are. So there's no way for you to check anyway if there's enough room in the destination array. So if you try to copy into a destination array and there isn't enough space in the array, anything can happen. Typically what ends up happening is you write past the end of the array, and if you write too far, your program eventually crashes. If you don't write far enough, your program keeps running, but you've probably overwritten some information that you didn't want to overwrite. String copy cannot copy a string onto itself. So if the strings overlap, then the behavior of string copy is undefined. Right? It might give you the result that you're looking for. It might give you something else. If you're careful with the sizes, you won't get there won't be any problems writing past the end of the array, but you may not get the result that you want. If either pointer, sorry, where's source and destination? So if either pointer is not a pointer to a null terminated string, it's not guaranteed to work either. Right? So in C, the library assumes if you're using strings, they are all null terminated. If they're not for some reason, anything can happen when you call string copy. And that's true for any function in the string library. Right? If you pass in a pointer to an array that's not null terminated, anything can happen. Okay, so how does string copy work? Well, I mean, it's just going to iterate over the characters of the source array until it finds the null terminator. Right? As it's iterating, it just copies the characters into the destination array. So using an index, we can write it like this. Right? Notice here I'm declaring I before the loop. Right? I'm doing it because I need I after the loop here. Right? I need I after the loop because I want to copy the null terminator. So we'll see how this works in just a second. Okay, so I'm going to start copying from the first character of the source array. Right? I want to copy as long as the character I'm copying is not the null terminator. Right? So as long as the character I'm looking at in the source array is not the null terminator, go ahead and copy the character into the destination. Right? So I can just copy the character at the ith location of the source into the character at the ith location of the destination. Right? Again, remember, this is not necessarily the first character in the destination. This is not necessarily the first position in the actual destination string. Right? If someone passes in a pointer to the middle of a string, that's going to start copying into the middle of the string. Okay, after the loop is done, right? So remember, this loop does not run if the source character is the null terminator. So we have to remember the last thing to do, copy the null terminator, which is why I need I to be available to me after the loop. Right? So after the loop, I can copy in the null terminator, and then we're done. We can simply return dest in this case. Right? All right, so just like string length, is there any questions about this implementation here? Anybody? All right, again, it would be nice if you could interpret this into the pointer version, right? So here, source I becomes dereference, so star, round brackets, source plus I, right? Dest I becomes star, round brackets, dest plus I, right? And source here becomes, source I becomes star, round brackets, source plus I, right? And then copy the null terminator, again, using pointer addition and dereferencing. This is a more sophisticated version of string, well, more sophisticated. This is a trickier implementation of string copy. It's playing the same trick that string length played with the plus plus and the dereference. Right, so this one is extra tricky because there's an assignment sitting in the condition. Right, so in C, this is also true in Java, by the way. The result of an assignment actually has a value. Right? So right there, you're looking at an assignment statement. So this is not a typo. This is actually correct. So you're looking at an assignment statement. Right? We're assigning something. Right? This is some character from the source string. Right? This is some character in the destination string. We're performing an assignment. Right? Okay. So the value of an assignment is simply the value of the left-hand side after the assignment. Right? So x equals 1. The value of that assignment is 1. Right? And y equals 2 times 7, the value of that assignment is 14. Right? So it's just the value that you assign to the left-hand side. Right? So here, if that character there happens to be the null terminator, the result of this assignment is 0. Right? 0 is false in C. So the assignment occurs, right? We copy the null terminator, but now the loop stops. So this is very tricky. This condition has a side effect, and it's using pointer dereferencing and pointer addition to do the assignment. So this one's quite tricky. Inside the loop, you don't have to do anything because all of the work is being done by the condition, right? Which is very strange, right? This is a very, if you're not used to looking at C, this is a very strange looking implementation. In this particular implementation, we are manipulating the destination pointer, right? So there's a dest plus plus there, which means we're changing the value of dest. String copy has to return the original value of dest, which is why we save the original value back here, right? So that we can actually return the original pointer that was passed into the function, right? So that condition there, if you can decipher that, again, good for you, but you're never going to be asked to do that on an exam or a test in this course. Right, or an assignment. On assignment, you can write this if you want to, right? But again, no one's going to ask you about this on a test. This is very cryptic. I think even for experienced C programmers, this is quite cryptic. Okay. I guess once again, it's worth pointing out that there's a reason why we need string copy, right? In C, strings are just arrays. You can't copy arrays, right? So you can't copy arrays via assignment. So you need to do something, either write a loop, call a function to copy the array. And so to copy strings, the library provides you with a function to do so. Okay, any questions about string copy and its implementation? All right, carrying on. I don't think I'm going to do this whole notebook because it's very repetitive. The techniques that are being used here are all very similar, right? Basically, all these functions are looking for the end of the string by checking for the null terminator, and then they're doing something with the characters in the string. String cat is another funny one, especially if you come from Python and Java. So in Python and Java, if you join two strings, so x plus y, or s1 plus s2, right? The languages take care of allocating the memory for the joined string, right? So you join two strings, you get back a new string every time. There's no way to, strings in both languages are immutable. So there's no way for you to change either string, right? The only way you can concatenate two strings is to return a new string. In C, that's not the case. So in C, strings are mutable, right? You can go into the array, change the characters of the string. So string cat in C concatenates two strings, but it writes into the array of the first string. Right? Sorry, it writes into the array of the string that you are concatenating to. Right? And so this one's a bit different. So this one doesn't do any memory allocation for you. Right? It assumes that when you join two strings, there is enough room in one of the arrays to hold the result. So stringcat copies the characters from that string onto the end of that string, and it assumes that the array, that the array holding the characters of that string is large enough to hold all of the characters of both strings combined, plus the null terminator. Right? So if this string has length 5, and that string has length 5, after the concatenation, this string now has length 10, plus there's a null terminator on the end of the string. So you need 11 characters to hold the result. Like string copy, it returns the destination pointer, the original destination pointer, so that you can pass the result of stringcat to another function if you want to. Okay, so here's an example where we're going to concatenate two strings of length 5. Remember, the destination array has to have length 11 or capacity 11. Right? So S is going to be my destination array. Right? Why does it need 11? Because there's 5 characters in both strings, plus I need the null terminator. Right? So we're going to concatenate T onto the end of S. So after the concatenation, we should have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So stringcat, print the result down here. Right? And we get exactly what we expected. Right? Okay, so what happens if S is not big enough? So unfortunately, it often works. So in a little toy program like this, right, S is not large enough to technically hold the concatenated result. It's probably going to work in this case. It does, right? Or it appears to work anyway. Right? But what you have to remember in this example is that stringcat has just written past the end of S. Right? So it's stuck a null terminator after the 9. And we don't know if it overwrote anything important or not. Right? We could play around, try to look at T, see if it overwrote T or something like that. Right? You might not find any errors that have occurred, right? But it has gone past the end of S's array. And so an error has occurred here. There's just no evidence of it when you print out the result. So you have to be careful there. I guess if we make it small enough, we might get something funny. Yes, so we make it small enough. Oh, wait, sorry. Oh, right, can't make it that small. We need at least 6, right? 1, 2, 3, 4, 5, 6, yes. Do we get it? No. So even if you make the array very small, right, it can only hold these characters technically, plus the null terminator. Right? Stringcat still appears to work. It actually hasn't worked the way it's supposed to. Right? It has written past the end of S. So watch out for that. Stringcat cannot concatenate a string onto itself. Right? If the strings overlap, the language says anything can happen. Right? And again, you have to pass in proper C strings, right? So they have to be null terminated C strings. Okay, I guess one more. We'll look at string comp and then we'll jump to the next notebook. String comp is basically comparing two strings the same way that Java compares two strings, right? So in Java, if you want to compare two strings for dictionary order, you just call compare to. String comp is exactly the same thing. It's just you call it in a slightly different way. Right? So if two strings have the same characters and the same length, string comp returns 0 when you compare them. Right? In other words, they're equal. If S comes before T in the dictionary, right? So aardvark and zebra, you get back a negative result. If S comes after T in the dictionary, you get back a positive result. Right? So exactly the same as in Java. So notice it returns an int. Even though I'm storing the result in a bool up here, that's probably a little bit misleading. It actually returns an int, right? It returns negative if S comes before T in the, if left-hand side comes before right-hand side in the dictionary. It returns 0 if left-hand side is equal to right-hand side as strings, right? And it returns a positive value if left-hand side comes after right-hand side in the dictionary. Here's a little program. Can I run the program? I probably have to run this from the command line. So this little program here basically shows you how to use string comp to compare two strings passed in on the command line. Right? Your first string, hopefully you've done assignment 2? You've done assignment 1. So I don't remember in assignment 1 if I asked you to use command line arguments or not. Assignment 4, sorry. So this is an example of using the command line arguments in C. Your command line arguments, that looks funny. It should look funny to you, right? What the heck is that argument? So to read this argument, argv is an array, right? So this is how you read it. So argv is an array of something. It's an array of pointers to car. So this is trying to tell you that argv is an array of strings, right? That's all it's saying here. The first string in argv is the name of the program, or more precisely, it's how you ran the program from the command line, right? So your first actual command line argument, if it exists, is argv1. So this program expects you to pass in 2 strings, and it will compare them using string comp, right? argc, so that argument there, is the number of command line arguments plus 1, right? The extra 1 comes from the fact that the first argument is the name of the program, or more precisely, it's how you ran the program from the command line, right? So here, arg3, if it's not 3, there's a problem, right? I want 2 arguments, you have to add 1. So that's the weird thing about argc and argv, right? So I want 2 arguments, so if it's not equal to 3, there's a mistake. fprintf, round brackets stderr, prints something to standard error, right? So this prints an error message to your standard error instead of standard output, right? Exit with an argument after it sets the exit status of your program. You should set it to some non-negative value to indicate that an error has occurred, right? So that in bash, remember you can get the exit status of a command. This is how you set the exit status in C, right? You call the exit function. You can also call return. Return space 1 would work here too, right? Because main returns the exit status of the program. Okay, so argv1 and argv2, those are just the 2 strings that were passed in as command line arguments. So there's argv1 and argv2, and now just call string comp with your 2 arguments, and away you go. All right, so that's all I want to talk about the functions in the string notebook. There are more. So you can string chr and string rchr is basically index of from Java. String is basically index of where you search for a substring in a string. I guess these are important, so I guess we should talk about these and then jump on to the next notebook. All right, so somewhat confusingly, the string library includes functions that manipulate memory. So there's a function called memcopy, and there's a function called memmove. All right, so these are both similar. So they both copy memory from one place to another. Memcopy has some restrictions that memmove does not. So if you want to copy a chunk of memory in C, a contiguous chunk of memory, then memcopy is the fastest way to do this. Right? Memcopy has the following signature. It takes in a pointer to the memory where you want to start copying from. Right? Now memcopy will copy any memory. So its pointer type here is void. Right? So it's a void pointer. Right? Remember what a void pointer is? A void pointer can point at anything. Right? So this isn't limited to copying strings. You can copy whatever memory you want. Right? You just pass in a pointer to the first element of the memory you'd like to copy. Right? And you pass in a pointer to the location in memory where you'd like to copy to. Count is badly named, right? It is not the number of elements to copy. It's the number of bytes to copy. So the number of units of memory that are a multiple of car, right? So for count, you typically have to multiply the number of elements by the size of the element that you're copying, right? So if you're copying an array of int, it's going to be n times size of int, where n is the number of elements you'd like to copy. Right, so copy from here into here, that amount of memory. So what do we got here? We have a long example here. Okay, so print I array prints an int array. Print D array prints a double array. There's no way to print an array in a single function call in C, right? Not like in Java or Python, right? Python or in Java, you print a list, you just pass in the list and magically the list gets turned into a string. Right? You want to print an array in Java and C, you got to do it yourself. Okay, so to print the array, I'm going to print out the elements. How am I doing this? It's the first element of the array. Right? Notice in C, you don't have to check if the array is not empty. Right? In C, there are no empty arrays. So I know that the first element of the array exists. Right? So I can safely do that first line in C. N is the number of elements that are in the array. So I'm going to print out the first element, then I'm going to print out every other element, but I'm going to put a comma in front first. Right? So first element, then comma space second element, then comma space third element, and so on and so on and so forth. Right? So to print the elements, I'm going to use printf. I'm just going to use array indexing here to get the element of the array. Print darray is exactly the same, except it prints double values. So when you print the values, you use %f as your formatting string. All right, so here's my array x. It's an array of int. I would like to copy the array x into y. So y has sufficient size to copy the elements of x. Remember, this is not a string, right? So you don't need the extra one space at the end. So if I want to copy 4 ints, I only need an array that can hold 4 ints, right? I don't need to hold 5. Okay, how do you copy the arrays? So I want to copy x into y. Into y. Right? How much memory do I want to copy? Well, I want to copy 4 elements, right? But I need to multiply by the size of the element type. So count times size of int here. Right? A very common error here is to do count, and that's it. Right? So if you do that, you end up copying 4 cars worth of memory, right? Not 4 ints worth of memory. And so when you look in X, you will only have the 1, right? You won't have the 2, 3, and the 4, at least on my computer. Right? Okay, so just like all of the other string functions, memcopy, you don't have to start copying from the front of an array. You don't have to copy into the start of another array. You can copy from and into wherever you want to, right? You just manipulate the pointer to indicate where you're copying from and to. So here's double, so -1 through -7. I want to copy 4 elements from double into CPY. Now, which 4 elements do I want to copy? So I'm going to start copying from double plus 3. Right? Remember what that means? That's just the 4th element of double. So 0, 1, 2, 3. So we're going to start copying from the -4. How many elements are we going to copy? We're going to copy 4, right? But remember, that argument is not the number of elements, it's the amount of memory you want to copy. So 4 times size of double. So we're going to copy that memory into CPY. So let's see if that actually works. And it does. Right? So the first array, we copied the 1, 2, 3, and 4. Right? In the second loop, in the second call to memcopy, we copied the last 4 elements of DBL, I think. Yes, of DBL. Okay, can you copy a string into a string using memcopy? You absolutely can. Right? Can you copy part of a string into another string using memcopy? Sure, why not? A string's just an array, so you can copy the memory of one array into another array. Right? So here, the source is this, that, and then. The destination is why, what, and when. I'm going to copy starting from source plus 5. So the 6th character of source, which is that, the start of that. Right? I want to copy into the destination at the 5th character. So that's going to copy on top of the starting at the what. Right? How many characters do I want to copy? I want to copy 4. Right? I don't have to write times size of car here because size of car is guaranteed to be 1. So this will copy 4 cars. And notice that the destination array is in fact why, that, and when. Right. Okay, so there's how to use memcopy. Memcopy has a significant limitation to it though. So where is it? Here it is. Right. The big problem with memcopy and the problem that the limitation that many programmers overlook is that you cannot, the memory that's being copied from and being copied into is not allowed to overlap. Right? So if you want to copy memory from one chunk of an array into another chunk of an array, into the chunk of the same array, and the part that you're copying overlaps with one another, memcopy is not guaranteed to give you the correct result. Right? So the memory being copied from cannot overlap with the memory being copied into. Right? So if you copy the last 4 elements of an array, if you copy the first 4 elements of the array onto the second, third, and fourth elements of the array, there's no guarantee that memcopy will do the right thing, right? Because those chunks of memory overlap. If you want to copy overlapping memory, you have to use memmove. So memmove is basically the version of memcopy that you use when the memory that you're copying overlaps with itself. Right? Memmove is slower than memcopy because it has to check, is the memory overlapping? Right? And if the memory is overlapping, it now has to do something else. Right? Memcopy simply assumes the memory is not overlapping, and it does the fastest thing possible to copy the memory. Right? It works the exact same way. Right? So it's the exact same function. You tell it where do you want to copy into, you tell it where do you want to copy from, you tell it how much memory do you want to copy. Right? So it's the exact same thing, except it's the version that you use when the memory that you're copying might overlap. I think this example here basically does a shift. So in 124, when you're implementing lists and other list-like structures, we often have to shift the elements of one array forwards or backwards in the array, right? How did you do it in 124? You wrote a loop, right? How should you do it in 220? Use memmove, right? Memmove can move a chunk of memory in an array into another chunk of memory in the same array, right? It's much faster than writing the loop yourself manually. Right? Because it has access to operating system functions that can move chunks of memory. Sprintf, we don't, oh wait, do we need to talk about, we should talk about sprintf, shouldn't we? I guess we should talk about sprintf. Sorry, I was hoping to get through this notebook and start the next one, but that's not going to happen, I don't think. All right, so sprintf. So we know what printf does, right? Printf prints something, it's formatted print to standard output. You don't have to print the standard output in C. You can print to lots of different places in C, right? So you can print to standard error. You could read from standard input if you wanted to. You could read from standard input, right? You can print into a file that you own or you have access to, right? But you can also print into a string. So that's what sprintf is for, right? The S indicating string, printf indicating it's formatted print. Right, so this works exactly the same way as printf, except you tell the function which string would you like to write into. So sprintf will print some stuff according to a formatting string, right, into an array, into a string that's pointed at by buffer. Right? So it behaves exactly the way that printf behaves, except you now print into a string. Right? And so this is useful. So if you want to computationally, if you want to compute the values of a string, you've got a bunch of data that you want to put into the string. Sprintf is the function that you want to use. Right, so for example, you have an int, and you want to get the int representation of the string. Sorry, you want to get the string representation of the int and put that into a string. It's sprintf that you're going to use. Okay, so how does this thing work? So it works exactly the same way as printf, right? Except you tell it where are you printing into. So here's my source string, it's 0, 1, 2, 3, 4. Right? I want to copy, what am I doing here? Oh, so I'm going to use sprintf to copy a string. Right? So there's my destination string. Right? It has to be at least 6 characters long. Right? So in other words, 5 plus 1. Right? And now I'm going to use sprintf instead of string copy. Right? So how do you use sprintf instead of string copy? Well, you use sprintf, right? You tell it, I would like to copy into destination 1. Right? How would I like to convert the data? Well, I want to convert my string as a string, so there's your formatting string. Right? What string would you like to copy? Well, I'd like to copy the source string. Right? And that copies, in this case, that copies source into destination 1 exactly the same way that strcpy would do it. Right? So there's your source, and there's your destination. Right? Okay. Just like all of the string functions, right? Because it takes in pointers, you can control where it prints into or where it starts you control where it prints into. Right. So here is my destination string. Right. It's A, B, C, D, E with 5 hyphens in it. I would like to overwrite the hyphens with the 0, 1, 2, 3, 4. Right. So I'm going to call sprintf. Right. Where do I want to print into? Well, I want to print into destination 3, but I want to start at that element of destination 3. So that element is just dest3 plus, in this case, length, which is 5. Right. I want to convert the data as a string. Right. And that's the piece of data that I would like to convert. Right. Right there. So there's dest3. Oh, what is it? Sprintf returns the number of characters that were printed. Where to go? The return value is the number of characters, not including the null terminator, that were written into the buffer. Right. So however many characters it printed, that's the return value. Right. So if you want to know how many digits are in an int, you could print the int using sprintf and then look at the return value to determine how many digits were there. Probably not the best way to do it, but that it definitely works. Right. Okay, copy the end of a string into a destination array. So here's sprintf. I'd like to copy from S, but I want to copy the 220. And I'd like to copy that into the destination array. Right, so into this array here. Right, so what string do I want to print into? I would like to print into destination 4. Right, where do I want to start printing from? Or what do I want to print? I'd like to print the string S starting at the 4th character. Right, and when I print that, I'm going to convert the data as though it were a string. Right, and so destination 4 becomes 220 in this case, and the number of characters that sprintf wrote was 3. Right. Okay, so you can also, using sprintf, you can also get the same functionality that stringcat gives you. Right, when you print into the string, so you want to concatenate 2 strings. Right, when you specify the destination string, you just specify the end of the destination string. Right, and then sprintf will print onto the end of the destination string. Okay. So in Java and Python, you basically use the plus sign to do string concatenation, right? And then in Java, everything gets a toString method. So that lets you get the string representation of a bunch of stuff that you've concatenated together, right? So you take a string, you concatenate an int, and then concatenate a double, and then concatenate a Boolean, right? After everything is said and done, in Java you get a string. Right? And so if you want to do something like that in C, you use sprintf. So here is the string equal to the department CISC. Right? There's an unsigned int equal to 220. So we're going to try to print sys220. Here's a car indicating this is section A of sys220. Right. I would like to join the sysc, the 220, and the A all into one string. C doesn't have an overloaded plus operator, so you can't do string concatenation using plus. Right. What does it have? Well, it's got this sprintf function, which admittedly is not as nice as plus. Right. Okay, so I'd like to write sys220A into an array. Right. So I need at least sysc is 4, 220 is 3, and A is 1. So I need at least 8 characters plus 1 for the null terminator. So my string needs 9 characters in it. All right, I would like to print into course. What would I like to print into course? Or how do I want to format the information when I print it into course? I'd like to print the department, the number, and then the section into course. Right? I would like to format the department like it was a string. Right? I want to interpret number as though it were an unsigned int. So there's your %u. Right? I would like to interpret the section as though it were a character. So there's %c. Right? Sprintf does what it performs whatever calculations it needs to do. Right? So it copies, it formats sysc as a string, 220 as a number, as an int, and A as a character. Right? Print the course, and you get sys220A. Right there. Right. Okay, so the trick to using sprintf is to remember your conversions, right? So here I'd like to generate the string equal to the year hyphen month hyphen day, right? For the month and the day, if they only have one digit in them, I'd like to put a 0 in front of them, right? So 2024 month 11, and then for the day I would like to be 05, so that'd be today's date. sprintf can do that for you, right? So here our formatting string %04u means, so first of all, the u is interpret the value as an unsigned value. The 4 means use at least 4 characters to print the result. Right? The 0 means if you use less than 4, stick zeros in the front, right? So that a total of 4 is used. Right? The hyphen means print the hyphen. Right? %02u means treat the argument as an unsigned int. So treat the month as an unsigned int. Right? Use 2 characters to print the month. Insert zeros in the front if we don't need 2 characters. Right? And so when you do this, did we run it already? Yeah, we already ran it. Right? So the example here, 2023-10-03. Right? The 0 comes from the fact that there's a 0 and then a space, a width modifier here. Right? Okay. Format a space into a postal code. Right. So here's a postal code. A1B2C3, right? I would like to insert a space after the B in between the 2 in the output string, right? So in the output string, I need 7 spaces, right? 6 for the postal code, 1 for the space, 1 for the null terminator. So the formatted string needs 8 characters in it, right? How do I format this into a string? Okay, so here we got %.3s, right? P code. So P code, in this case, is the start, right, is a pointer to the A, right? P code plus 3 is a pointer to the 2, right? So we're going to treat both of these as though they were strings, so that's the S, right? Do I explain what the dot is anywhere? I don't explain what it is here. Okay. The 3 means use 3 characters in the result, right? The space here means print the space in the result. And I do not remember what the dot here means, so we have to look this up. I don't want to look it up right now. The dot means something important here, but I don't remember what it means. Actually, it is worth looking it up, so hang on. Printf, C. Where's the one that here it is. Okay, so when you look at the documentation for this, and it is worth looking at the documentation for this at some point in time, right? The thing that you should remember is, so the thing that you should note is that the documentation is very long, right? It's huge, right? So this is not the easiest function to use, right? It's got lots of options that you can pass in for the formatting string, right? And notice there are many versions of the function, right? So all of the printf functions, they all behave the same way. So once you learn how to use one, you can use all the rest, right? Printf prints to standard output. Fprintf prints to a file, right? Standard error is considered a file, so you can print to standard error. Sprintf prints to a string, right? And then there are underscore versions of all of them, right? There's also an there's also an snprintf, right? So the underscore s versions, I believe, are considered the safe versions. So 5, 6, and 7. Yes. So the last examples there, these are quote unquote safer versions of the printf version of the functions, right? And so they actually do some error checking for you, but they're limited in the type of error checking that they can do. Okay, so what does that dot do? So to find out what the dot does, it's here somewhere. Here it is, dot. Optional, so followed by an integer number or star, or neither, specifies the precision of the conversion. In the case when stars, so we're not using stars, we don't ignore that. but after the argument supplying the minimum field width, if the value of this argument is negative, is normal. You know what? I don't actually remember why I put it in. Followed by the integer, or neither. Specifies the precision of the conversion. So, oops, sorry. Oh, so now I remember. Sorry. String. Right. Okay. So the .3 here means, oops, sorry. It's forcing it to use 3 characters in the output. And so when you print it out, that's 3, and here it's 3. I don't think it's actually, oh yes, it is needed in this case. I'm sorry, I'm being a dummy. Okay, here, look, we're telling it to format P code as a string, right? So if we tell it to format P code as a string, then as a string, it's A1B2C3. But I only want the first 3 characters of P code, right? So if I just put in 3, if I just write 3, that's the minimum field width, right? So at a minimum, it's going to use 3 characters to print out the string, right? There's 6 characters in the string, so it's going to use 6. The dot forces it to use 3. So .3 here means use only 3 characters from the string. So that forces it to use the first 3 characters of P code. The next one thing here, oh, sorry. The next thing here forces it to use the last 3 characters of P code. Right? And so that's how you can format that string and print it to a string that way there. All right, I guess that we should end it there because we are at the end of the lecture. We have a few minutes. Does anybody have any questions about any of the functions that we talked about today? All right, that's it. I will see